This video covers basic chart multi-series line chart. The structure of this video is as follows: visual code walkthrough, JavaScript code build, and the summary. Alright, let's get started. Visual code walkthrough. We will cover the D3.js.org website multi-series line chart example. What is crucial to understand about this chart is that the data is a two-dimensional array where we have data on 3 cities, and for each city we have data on 366 different days. Because the data gets processed into an array of 366 JavaScript objects, where each object is a specific date and the temperature for 3 different cities, we have to change the data into a more D3-friendly format. Because we want a line for each city, we have to reconstruct the data so that we have one JavaScript object for each city. Then in each city, we want to have a time series of dates and temperatures on that date. Because D3 data functionality takes in an array of JavaScript objects, we have to create a nested dataset. This dataset will consist of an array of JavaScript objects where each one represents a city. Then, inside of each object, we need a key value pair that then references an inner array of objects where each of these inner objects is a date and a temperature. Once we have this array of objects with an inner array of objects inside each of them, we can bind the outside objects to SVG group elements, and we can bind the inside objects to an SVG path element based on the D3 path generating function. We will save the data from the example into a file called data.tsv. This file is the one that will be loaded asynchronously using the D3.tsv request functionality. The document starts with the doc type, meta character set, and CSS styling. This is the standard HTML doc type, meta character set definition, and CSS styling for the D3 data visualization we are making. Next, we go into the JavaScript section of the document. First, we load the D3.js JavaScript library from the web. This uses the D3 code hosted by the D3.js.org website. Next, we go into the D3 code that will create the multi-series line chart. The D3 margin convention sets up the SVG container size as well as defines the inner drawing space. Next, we have a D3 time formatting function which will parse a date string formatted in a certain way and convert it into a JavaScript date object. Next, we have a timescale function for the x-axis data. This code creates a timescale scaling function where the range goes from 0 to the width of the inner drawing space. Next, we have a scale linear function for the y-axis data. This code will create a scaling function where the range goes from the height of the inner drawing space to 0. The height and the number 0 are reversed so that numbers passed into the scaling function will be converted to numbers that act as if the SVG coordinate space has been inverted along the y-axis. Next, we set up an ordinal scaling function for the colors that are going to be used for the different series of data ranges. We are using the category 10 color scale that D3 includes. Note that the domain is not yet set. Next, we create the x-axis function. We pass in the x-scale function we created earlier and then give the axis an orientation of bottom. Then we create the y-axis the same way. We pass in the y-scaling function we created earlier and give the axis an orientation of left. Next, this code defines the D3 path generation function. This uses the D3 path data generator functionality. For x values and y values, the code defines specific accessor functions. The dataset we are looking at is comprised of dates and temperatures. This creates a function which will be called later. The next code creates the SVG container and the inner drawing space. The next code is where D3 does the asynchronous call to the server to get the data and then builds the chart. In this case, the callback function is an anonymous function. Note, this example uses D3.tsv for tab-separated values, not D3.csv for comma-separated values. Let's go through the callback function section by section. First, we have code that looks at the first data element, gets the object keys, and then defines the domain of the ordinal color scale based on those keys. This is constructed in a series of steps. First, data0 returns the first JavaScript object. Then the D3.keys functionality looks at each key value pair in the object and returns only the keys. This list of keys is returned as an array. Next, the JavaScript array filter method is used to apply an anonymous function to each element of this keys array. The anonymous function returns the element as long as it is not equal to the string date. Lastly, this array of keys, which represents all of the different cities, is used to set the domain of the color ordinal scale function. This ensures that when a city in the domain is used, it will be colored the same way everywhere on the chart. This code iterates through the array of JavaScript objects. For each JavaScript object, it does one thing. It converts the date string into a JavaScript date object. It does this by using the parseDate function we defined earlier. The parseDate function takes in a string, and using the format we specified, it creates a new JavaScript date object. Then it assigns it right back to the d.date key. Next, this code does the hard work of organizing the data in a way that is usable by the D3 pattern. First, a function is applied to every element in the color domain, which is the 3 city names. This function returns an object with 2 key value pairs. The keys are the string name and the string values. The value of the string name is the name of the city. The value of the string values is an array of 366 objects where each object has the date and temperature inside, based on the data from the data.tsv file. The date is a JavaScript date object. The temperature is a JavaScript number. As you can tell, this is the nesting of data inside of data. This will be used to first bind the cities to SVG group elements and then use the interior data of the cities to bind the temperatures to an SVG path. So overall, we get an array of 3 JavaScript objects representing the cities. Each of these JavaScript objects has an array of JavaScript objects inside, where each interior object represents a date and temperature. This array of 3 JavaScript objects is then assigned to the variable cities. Next, we set the domain for the xScale function. Now that we have the data, we can set the domain of the xScale function by using the d3.extend method. An anonymous function is used to get the date out of the data objects. This returns an array containing the minimum and maximum dates, which is used to set the domain for the xScale function. Next, we set the domain for the yscale function. To get the domain, this code figures out the minimum and maximum temperatures for the cities. Because the data is nested, to figure out the minimum and maximum temperatures, 2 anonymous functions need to be used. The inner anonymous function figures out either the minimum or maximum temperature for a given city. The outer anonymous function figures out what the minimum or maximum temperature is for all the cities in the data. Next, we create the x-axis. Then we create the y-axis and a y-axis text label. Then we use the D3 pattern to bind the city JavaScript objects in the cities array to SVG group elements. The data operator takes in an array of 3 JavaScript objects. Each JavaScript object in the array is a city. So each SVG group element with a class of city will have bound to it a city JavaScript object. This collection of SVG group elements is then assigned to a variable named city. And then finally, we draw the path for each city. Since each SVG group element already has a JavaScript object bound to its data attribute, we can use this object to generate the necessary data. For each SVG group element in the city variable, we append a path. For each path, we then define the D attribute, which is what generates the line. The value of the D attribute is the set of SVG path instructions generated by the D3 path generator function we defined earlier. The style of the stroke is based on the city name passed to the color ordinal domain function. Because we defined the domain earlier, all this does is return a color to be used for each specific city. Lastly, for each city SVG group element, we have to add to the chart the name of the city at the very end of the line. This is done through the D3 pattern. First, append text to the SVG group element each city represents. Then to this text, we bind a JavaScript object using the d3.datum operator. The JavaScript object is created by using the data attached to the SVG group element for each city. The name keys value is the name of the city. The value keys value is the last JavaScript object, which represents the date and temperature in the array of JavaScript objects that lives in the SVG group element. This is the nested data. Then this SVG text is translated according to the last date and temperature after they have been run through their respective scaling functions. Then the X and DY attributes are defined. Finally, the actual text of the SVG text element is defined as the name of the city. We explore this further in the JavaScript console section. And that is the end of the callback function and the end of the D3.tsv function. When this is done, the graph will have been fully generated. Let's now build this part by part in JavaScript. JavaScript code build. Because in the web example, the building of the chart happens inside of a callback function, we will use a more simple anonymous function in the JavaScript console. Alright, to the JavaScript console. After downloading the data to a data.tsv file, starting the Python simple HTTP server and making sure D3 is loaded, we open the Chrome Developer Tools and go step by step building the visualization. We start by defining the callback error and callback data variables, which will be used to house the data we get back from the D3.tsv function. The first step from the example is defining the margins and the width and height of the inner drawing space. Next, define the date parsing function. Next, define the X timescale function as well as the range of the function. Next, define the Y linear scale function and its range. Remember to pay attention to the fact that the range has height first and then 0. Next, define the color ordinal scale function, which will be used to color the different cities. This is the D3 category 10 color ordinal scale that comes included in the D3 library. Next, define the x-axis function and provide it with a scale and orientation. Next, define the y-axis function and provide it with a scale and orientation. Next, define the D3 path generator function. This will use accessor functions to get the date and temperature from JavaScript objects. Then, each data point will be scaled according to the X and Y scaling functions. The interpolation for this D3 path generator function is basis. Next, define the SVG container and the inner drawing space. Next is where we are going to differ a bit from the code of the example. Instead of defining an anonymous callback function that does all of the generating of the chart in one go, we'll define a callback function that assigns the data and error to variables. We'll then use the callback error and callback data variables to build the multi-series line chart. Inside of the callback function, we have a console log of an array of the callback error and callback data.length so that we can see what is in each one of them. We can see that the callback error is null and that the length of the callback data array is 366 elements. Let's look at the first element. It is a JavaScript object where the keys are 3 different city names and the word date. The values for the cities are temperatures and the value for the word date is the date in a specific format. Currently, the data is organized as one date and the values for each city. What we would rather have are separate objects for each city and have them have a date and temperature for the time series of dates. This would make it easier to build a line path using the D3 pattern. Once we have the data, we extract the city names from the callback data array and assign them to the domain of the color ordinal scale function. You can see that the domain is the name of the 3 cities. Before we do the array for each iterator, let's take another look at the first element. When we expand the object, you can see that it has a date and the 3 city names and their respective temperature values. Next, we use the D3 array for each iterator to go through the array and change the string values to JavaScript date objects for each object. We then check to make sure the date was parsed correctly. Yes, it was. The date is now a JavaScript date object. Next, this code does the hard work of organizing the data in a way that is usable by the D3 pattern. Let's break down what happened into smaller steps. First, a function is applied to every element in the color domain, which is the 3 city names. You can see that the variable cities is an array of 3 objects. Each object represents one of the cities. Each city has a values key, which has a value of an array of 366 objects. Let's look at this array for New York. You can see that it is an array of 366 elements. When we click into the array, you can see that it is an array of 366 objects. When we click into the first object, you can see that it is an object with two key value pairs: the key date and its value of a JavaScript date object, and the key temperature with its value of a numerical temperature. When we click into the second object, you can see that it is the same as the first object, except that it is 1 day later than the first object and has a different temperature. So we can see how this code that assigned the cities created an array of objects for each city, which inside of it has an array of objects, each of which has a date and a temperature. By doing an array of objects inside of an array of objects, we can use the D3 pattern twice. Next, define the domain of the X timescale function and then check to see what the domain is. The domain of the X timescale function goes from October 1st, 2011 to September 20th, 2012. Next, define the domain of the Y linear scale function and then check to see what the domain is. Remember that since the data is really two levels of data, we have to use a JavaScript function to get the max and min temperatures for the city, and then once we have those, we have to get the max and min temperatures across all the cities. The domain of the Y linear scale function goes from 19.2 to 89.6 degrees Fahrenheit. Next, the X-axis is created. Next, the Y-axis is created. Next, create the SVG group elements, which the JavaScript objects which represent the cities will be bound to. Let's take a look at the first SVG group element with a class of city and see what data was bound to it. Here you can see the city name as well as the values array of the 366 JavaScript objects, where each of these objects has a date and a temperature. Next, we use each SVG group element to generate a path based on the data bound to it. Note that we added the last line of style fill none because we aren't using the CSS as defined in the web example. The last thing we do is add the text of the city name at the end of each path line. You can see the city name. We added in a class attribute that the website example does not have so that we can take a closer look at what was bound as data to the SVG text elements. The way this code works is that a JavaScript object is built right in the datum function and then bound immediately to the SVG text element. Let's look at what was actually bound. You can see that the data bound to the first city text SVG text element was an object with two keys, name and value. The value of the key name is the string New York. The value of the key value is an object that has the date and temperature. The date is the last date of data that is present in the data imported. This was constructed by using the array index properties of the values array of objects to get the last element. Using this object created anonymously and bound to the SVG text element, it is then placed by using a transform translate based on the properly scaled inner date and temperature data. And there we go, we have the multi-series line chart. Let's close the Chrome Developer Tools to get a better look. You can see the full picture. What is crucial to understand about this chart is that the data is a two-dimensional array where we have data on 3 cities, and for each city we have data on 366 different days. Because the data gets processed into an array of 366 JavaScript objects where each object is a specific date and the temperature for 3 different cities, we have to change the data into a more D3 friendly format. Because we want a line for each city, we have to reconstruct the data so that we have one JavaScript object for each city. Then in each city, we want to have a time series of dates and temperatures on that date. Because D3 data functionality takes in an array of JavaScript objects, we have to create a nested dataset. This dataset will consist of an array of JavaScript objects where each one represents a city. Then inside of each object, we need a key value pair that then references an inner array of objects where each of these inner objects is a date and temperature. Once we have this array of objects with an inner array of objects inside of each of them, we can bind the outside objects to SVG group elements, and we can bind the inside objects to an SVG path element based on the D3 path generation function. The summary. This video provided a visual code walkthrough, a JavaScript code build, and the summary.